How sustainable are our current agricultural practices? Could we be doing more for our environment while still enhancing productivity? In this era, agriculture is more than just sowing seeds and harvesting crops. It's a complex interplay of science, technology, and nature. It's about feeding an ever-growing global population, preserving biodiversity, and mitigating climate change. However, the current state of agriculture faces immense challenges. On one hand, we have the challenge of increasing food production to feed a global population expected to reach nearly 10 billion by the middle of the century. On the other, we must do so sustainably, without further degrading our precious soil and water resources, and while reducing greenhouse gas emissions. The intensification of farming practices over the past century has certainly boosted yields, but it's also led to significant environmental consequences. Overuse of chemical fertilizers and pesticides has led to soil degradation, water pollution, and loss of biodiversity. Deforestation for agricultural expansion contributes significantly to global carbon emissions. Moreover, issues like climate change, water scarcity, and loss of arable land are making farming even more challenging. Unexpected weather patterns, droughts, and floods can devastate crops. As the climate continues to change, these challenges will only become more pronounced. But it's not all doom and gloom. The importance of sustainable farming practices is being recognized globally. There's a growing interest in organic farming, permaculture, and other practices that aim to work with, rather than against, nature. However, to truly transform our agricultural systems, we need innovative solutions that can increase productivity while reducing environmental impact. We need to leverage scientific advancements and technological innovations. We need to make farming more precise, resource-efficient, and climate-smart. So, where does this lead us? What's the future of farming? Well, it's looking quite exciting actually. A revolutionary approach is emerging that promises to transform agriculture as we know it. This approach combines the power of technology with the principles of sustainability. It's about making farming smarter, not harder. To tackle these challenges, a revolutionary approach is emerging: precision agriculture. But what exactly is it? Let's delve deeper into this in the following scenes. Precision agriculture, or PA, is a farming management strategy based on observing, measuring, and responding to variability in crop and livestock production. This approach aims to take the guesswork out of farming, replacing it with evidence-based decision-making that leads to more efficient use of resources and better yields. The principles of precision agriculture are rooted in the understanding that not all parts of a farm field are the same. This variability can be due to many factors, including differences in soil composition, moisture levels, and even the slope of the land. Therefore, treating an entire field the same way can lead to waste of resources and reduced yields. Precision agriculture seeks to address this by measuring and responding to the specific needs of different parts of the field. The goal of precision agriculture is twofold. First, it seeks to optimize returns on inputs. This means using the right amount of resources, such as water, fertilizer, and pesticides, in the right place at the right time. By doing so, farmers can maximize their yields while minimizing waste. This not only increases profitability, but also reduces the environmental impact of farming. Second, precision agriculture aims to preserve resources. By using resources more efficiently, farmers can ensure that their land remains productive for future generations. This sustainable approach to farming is increasingly important in a world where resources are finite and environmental concerns are growing. Precision agriculture is not limited to crop production. It is also used in livestock production, where it can help farmers monitor the health and well-being of their animals, optimize their feed and water intake, and manage their grazing in a way that preserves the quality of the pasture. In essence, precision agriculture is about making smarter decisions in farming. It's about using data and technology to understand the unique needs of each part of a farm, and responding to those needs in a precise and targeted way. The practice of precision agriculture is made possible by the advent of cutting-edge technologies. Let us delve deeper into this. A farmer's ability to locate their precise position in a field, made possible by GPS and GNSS, is a game-changer in agriculture. With these technologies, farmers can map out the spatial variability of their fields, creating a clear picture of their terrain and its unique characteristics. This allows them to observe, measure, and respond to the variability in their fields, improving their ability to diagnose issues, make informed decisions, and execute their operations more effectively. This revolution in agriculture is not just about location, though. Sensor arrays mounted on GPS-equipped combine harvesters are another crucial component. These arrays are like the farmer's own personal lab, capable of measuring everything from chlorophyll levels to plant water status in real time. They can even measure the organic matter content, moisture levels, nitrogen levels, pH, EC, Mg, and K in the field. Imagine being able to know the exact condition of your crops at any given moment. It's like having a doctor's report for your field, right in your pocket. Then, there's satellite imagery. By pairing the data collected from sensor arrays with satellite imagery, farmers can gain an even deeper understanding of their fields. They can see how the variables measured by the sensors play out across the landscape, revealing patterns and trends that might otherwise go unnoticed. This is where variable rate technology, or VRT, comes in. Equipped with seeders, sprayers, and the like, VRT uses the data from the sensors and satellite imagery to distribute resources optimally across the field. It's like having a personal assistant that knows exactly where to put the right amount of water, fertilizer, or seed, ensuring that nothing is wasted and everything is used to its fullest potential. But technology and precision agriculture doesn't stop there. The recent advances have brought us real-time sensors directly in the soil. These sensors can wirelessly transmit data, providing an even more detailed picture of the field's conditions. And the best part? They can do this without the need for human presence, freeing up farmers to focus on other important tasks. In the world of precision agriculture, the future is now. Imagine a sensor in your soil that can wirelessly transmit data about your farm without human presence. That's now a reality with real-time sensors. This is not science fiction anymore, but the present state of precision agriculture, a revolutionary approach that is reshaping the way we farm. These real-time sensors, planted directly in the soil, serve as the eyes and ears of the farmer, detecting and measuring various parameters like moisture levels, nitrogen content, pH, and more. In essence, they paint a comprehensive and detailed picture of the farm, capturing the spatial variability of numerous variables that influence crop yield. This continuous stream of data allows farmers to respond promptly and appropriately to changes in the farm's conditions, optimizing resources and improving sustainability. Now let's take to the skies. Unmanned aerial vehicles, or as they're more commonly known, agricultural drones, are another game-changing technology in precision agriculture. These drones aren't just flying for fun, they're equipped with multispectral or RGB cameras, capable of capturing a multitude of images from above. These images aren't your typical holiday snaps. They're multispectral, containing multiple values per pixel, beyond the traditional red, green, blue values. This includes near-infrared and red-edge spectrum values, which are used to process and analyze vegetative indexes like NDVI maps. These drones do more than just snap photos. They provide additional geographical references such as elevation, allowing for the creation of precise topography maps. Armed with this data, farmers can correlate crop health with topography, leading to more informed decisions on resource allocation. In essence, these technologies are like having a team of experts on the ground and in the sky, working round the clock to provide the most accurate, up-to-date information about the farm. The integration of real-time sensors and unmanned aerial vehicles marks a significant stride in precision agriculture, enabling farmers to manage their farms with unprecedented accuracy and efficiency. These drones are capable of capturing imagery and providing additional geographical references such as elevation, enabling even more precise farming practices. With the right tools at their disposal, farmers are equipped to face the challenges of modern agriculture head-on, optimizing their operations while preserving our precious resources. With the detailed data collected, farmers can now correlate crop health with topography, resulting in optimized crop inputs. In the realm of precision agriculture, the use of drones and topographic maps have revolutionized the way farmers manage their resources. By painting a detailed picture of the land, these tools provide invaluable insights that lead to more efficient use of water, fertilizer, and other crucial elements. Imagine a drone soaring high above a field of corn or wheat. Equipped with multispectral or RGB cameras, it captures numerous images of the field. These images are then stitched together using photogrammetric methods to create orthophotos, essentially highly detailed, accurate maps. But these are not ordinary maps. They contain multiple values per pixel, including the traditional red, green, and blue values, as well as near-infrared and red-edge spectrum values. These multispectral images allow for the processing and analysis of vegetative indexes, such as NDVI maps. This wealth of data enables farmers to correlate crop health with topography. For instance, areas of the field that consistently produce lower yields may be linked to specific terrain features such as a slope that causes water to drain away too quickly. But how does this information lead to optimized crop inputs? The answer lies in the power of variable rate applications. This technology uses the data provided by the drones and topographic maps to optimally distribute resources. If a certain part of the field requires more water or fertilizer, the variable rate technology ensures it gets exactly what it needs. On the other hand, areas that are performing well with less input can continue to do so, reducing wastage and preserving resources. The result is a more efficient, sustainable form of farming. Water, fertilizer, and other resources are used precisely where they're needed in the exact quantities required. This not only boosts crop yields but also minimizes the environmental impact. Thus, precision agriculture holds great promise for a sustainable and productive future for farming. So, we've seen how precision agriculture, leveraging on technology, is revolutionizing farming practices. From the starting point of traditional agriculture, we've journeyed through the advent of precision agriculture, an innovative approach that's changing the game for both crop and livestock production. Precision agriculture, or PA, is all about observing, measuring, and responding to spatial and temporal variability. It's a management strategy that aims for sustainability while optimizing returns on inputs. The goal? To preserve resources while enhancing productivity. And how does it achieve this? Through the powerful blend of technology and agricultural know-how. We've explored the role of advanced technologies in precision agriculture. From GPS and GNSS enabling accurate location tracking and mapping, to real-time sensors and sensor arrays that measure a myriad of variables from crop yield and moisture levels to nitrogen and pH levels. These technologies provide a wealth of data that feed into decision-making processes, automating operations, and improving diagnoses. We've also seen how the advent of unmanned aerial vehicles, or drones, has made significant contributions to precision agriculture. These drones, equipped with multispectral or RGB cameras, capture detailed images of fields, which are then stitched together to create comprehensive maps. These maps, combined with geographic references like elevation, provide valuable insights into crop health and topography, helping to optimize crop inputs. And speaking of optimizing crop inputs, we've delved into how precision agriculture uses technology to efficiently distribute resources like water, fertilizer, and chemicals. Variable rate technology, for instance, applies resources optimally based on the data collected, reducing waste and maximizing yield. As we move forward, precision agriculture will continue to evolve, promising a sustainable and efficient future for agriculture. Advances in technology will continue to enhance its capabilities, making farming practices more precise and efficient, so it's clear to see the future of farming is here and it's precise.